Hello, everyone, and welcome back. Today, I want to talk to you about a question that I get very often every time that I try to introduce my generic components library, Dynolive. And this is, why do we need generic components? So let's answer this question. But first, let's talk about component-oriented frameworks. Of course, the most popular ones are Angular, React, and Vue. And when it comes to generic components, there is a very important concept that we must understand, and this is component encapsulation. There are four things that you want to encapsulate in your generic components, and this is our structure, behavior, styling, and unit testing. So structure. Structure refers to the component inputs, the data information that is coming into the component. The output events that get emitted from the component. And component layout. The layout is how the component is organized inside, the divs, spans, margins, or paddings. Behavior. So behavior refers to all the functionality that is encapsulated into the component. For example, in a table, you might want to write functionality to sort columns or drag and drop columns from one position to the other. So that is behavior. You want to encapsulate all this functionality into your generic component. Styling. By encapsulating your styling into your generic component, you can reuse this component all over your application, and the styling for that component is going to be ready. It's going to be out of the box. You don't have to style that component again and again and again. The styling comes ready out of the box. If you make changes to that component, if you need styling changes into your generic component, then your changes are going to get replicated all over your application. And why do I prefer styling at the component level? Well, maintaining global style sheets, it's very hard, especially when you work with a team that has multiple developers. Every developer is going to try to come style a given component their own way. They might not find existing styling and they might try to overwrite it. So it is hard to maintain when you handle the styling at the global level. You will end up with global style sheets huge, and it is harder to maintain. That's why I prefer to style my components at the component level. If I'm looking for some specific styling for a button, for example, you have to just go to that specific generic component and then make your changes in that component, and it will get replicated to the rest of the application. Unit testing. So one of the great benefits of using generic components is code reusability. So if you have to implement unit testing for your generic component, this code coverage is gonna get replicated in your component through your whole application. So there are four things that you want to encapsulate in your generic components. And this is our structure, behavior, styling, and unit testing. So now let's talk about the problem. Let's say you work in a very big company in which their main application is divided into three modules: members, orders, and users. Now you have three different teams working in these three different modules. Let's say you have a team of 2 developers working in the first module. You have a team of 3 developers working in the second module. And then you have one last developer working in your third module. So now let's say that in a given sprint, 2 developers in the members team are going to be working in 2 different stories at the same time. And as part of their stories, they have as a requirement to implement a table. So these 2 developers are going to be working in the same component, duplicating work. But now let's say that the first developer didn't realize and he introduced a defect as part of his implementation of the first table. And testing didn't cut the defect, so the defect is remaining there for the time being. Weeks later, in another sprint, there is a team member in the orders team that has to implement a new story. And as part of her story, she has a requirement to implement a table. She has a little conversation with the members team and they let her know that they already have implemented tables. And so she decides to go and copy some of that implementation to implement her story. And she brings a table. But when she brings a table, she also brings the defect that was not cut in the first implementation. Sometime later, the members team realized that they have introduced a defect as part of their first table implementation, and then they decide to fix the defect. The issue is that the second team doesn't realize that defect has been fixed in the first implementation, but they still remain with the defect in place. Of course, with this development pattern, this issue could replicate to other components in the application. And also, we are now fixing two things. We are duplicating efforts and we are not replicating fixes throughout our components. Another question that often comes up is why do we need a generic components library if we already have available third-party libraries like Angular Material? But third-party libraries like Angular Material contain elements or components that I will call low-level components. And this is because they are the building blocks of more complex components. Now, these more complex components, I call them higher level components. And that's because they use the building blocks that low level components provide us to build onto more complex components, higher level components. It is in this layer where we want to implement our generic components, where we want to encapsulate our structure, behavior, styling, and unit testing. So now let's talk about the solution. In our imaginary company, we still can use third-party libraries like Angular Material that will provide us with the building blocks or the low-level components that we will use to create more complex components or higher-level components. For example, Angular Material can provide us with the fields to create our own form and other components. Among the benefits of using this development pattern is that we will not be duplicating efforts. We will be consuming components from our library. And if there are issues presented in the original implementation, when we fix a defect in the generic component, that fix gets replicated throughout the application. In conclusion, when we use generic components, we avoid duplicating efforts and we take advantage of code reusability as fixed replication. So these are very good reasons to implement generic components as part of your development cycle. And well, thank you very much for having you here again and see you next time.